Here's where we get into problems about measuring the size of the universe. And these are four facts that you sort of, in a way, have to commit to memory in a way. The first one is that telescopes are time machines. If we look at Alpha Centauri, which is 4 light years away, what we are seeing is what it was like 4 years ago. But some galaxies have been measured at more than 13 billion light years away. This means we see it as it was and where it was 13 billion years ago. Stars have a lifespan. They burn out and die. We see it all the time in the universe. So many things we look at in the universe are gone. They're long gone. They're not there anymore. Then we have that the universe isn't stationary. It's actually getting bigger day by day. We can measure the speed. And the really weird part is, in just the last couple of years since you were born, we have learned that the speed of the expansion is actually changing itself. So it's like saying, how far away is that other car from us? And you go, well, the car's driving, it's getting farther away. And it looks like he's stepping on the gas pedal, so it's getting faster and faster. This makes saying what the size of the universe is a really big, vague question to ask. First thing we have is the time machine properties of light. So let's suppose there's a bug in the water, and there's a frog over here, and it feels the vibrations. It can't see the bug, but it heads towards the vibration source. By the time it gets to the source, the bug could be gone. So light waves spread out like this, and they travel at the speed of light that the universe allows. Light has a fixed speed, and it can't travel any faster. Just like water waves will have a speed that would be separate from waves in jello. Our universe seems to have been created 16 billion light years ago. So light has had 16 billion years to cross space, so we don't see anything further away than 16 billion light years because the light hasn't reached us yet. So we can't tell if the universe ends at that distance or not. We just have to wait and see. So if we look at this example I've set up here, we're on Earth. We can't see the light from these stars till they reach us. But light from a year ago reaches us in here. So we get a constant stream of information from things 1 light year away that they show up after 1 year. If we're looking at a star 10 light years away, we are seeing it as it was 10 years ago. We don't see anything beyond 16 billion light years, 16 gigalight years, because that light has never reached our telescope yet. We have to wait. So if we can't see anything farther than 16 billion light years away with our best telescopes, this is the end of time. The light has only had 16 billion years to travel. So if there's something out here 20 billion light years away, it could be there, but the light still has another 4 billion years to travel to reach us. So every single year we wait, the universe gets 1 light year wider, or 9 trillion kilometers bigger in all directions. So this year we just saw the light from here. Next year we'll see 1 light year deeper. So the further we stare, bit by bit, more things become visible as their light reaches us. So we find ourselves seemingly in the center of creation, whereas this big ball of stars around us, about 16 billion light years across. Does that mean someone living out here sees emptiness when they look beyond? We don't know. They may see themselves in a bubble 16 billion light years across. So we look like we're in the center of the universe because we see nothingness out here. That just means the information hasn't reached us. So let's take a look at it this way. Call this Eternity's Road. There's a family at some distant location, and they send us a photograph in the mail. We can't see them. We get no information about them at all until that letter arrives at the speed of light. They send it off the day you're born, and they are 100 light years away. So it is going to take 100 years for that letter to reach us. By that point, the picture you get is 100 years old. So you like, oh, look at my cousins way off. I should visit them one day. Long too late. Their cabin is in ruins. They've all long died. Indeed, the entire village around them, all crowded. You can see in the background the lights from the hundreds of other houses. They're all gone. You are seeing it as the past. And the weird part, let's say there's a survivor in this town, they're just getting the message that you were born. So there's this time machine effect that everywhere we look deeper in the universe, it's younger and it's brighter than before. So this means if we could stare back far enough, we could see the light when the universe first burst into existence. Seeing deep enough would allow us to see the beginning. When is that going to happen? We don't know. How much farther does that road go? We have to wait for the mail to arrive. This means it is possible that our telescopes one day could see back in time and see the Big Bang. What it is right now, we can stare further back and we can see younger galaxies, brighter galaxies, galaxies forming. So in a way, our telescopes let us see a picture like this. We can look and find stars at every age. And between all those photographs through time, we can assemble them and get an idea of the life cycle of a single star by seeing pictures of the stars at every age along the way. And so we could get 20 pictures of a human being at different ages from different humans and predict what the life of one human would be like. So this is a really cool advantage of astronomy, that we see the past and we can see it at any point we want. We can look back another year, another 20 years, and see different stars in different growth phases. And so that allows us to predict what our sun may look like. If we see a sun that's 100,000 light years away, right, and we see it on the edge of exploding, we go, oh, that's what our sun's going to do in 100,000 years. This takes a lot of work, but they've basically got an entire time machine of telescopes looking up and assembling the order of the universe's creation. And not surprisingly, the further back we look, okay, we look back 3 million years, the stars are bright, and the further back we go, the brighter they get, okay? So really big stars burn for 3 million years. Really small stars burn longer. Big stars are like a big campfire. They burn quickly. So when we look further back in time, the stars get smaller. We only see these really ancient old stars. So there are more stars in the distant past. We don't see as many big stars because their light burned out and hasn't reached us yet. Now the question is, if right now we can see 16 billion light years in the past, and next year we can see 16 plus 1 billion light years away, how long will we wait till we never see starlight again? And only time will tell. Right now, the light has reached us from here. But is there a star 200 billion light years away that one day will reach us? We don't know. Every year, the universe gets 1 light year bigger, and we have no idea when we will stop seeing anything, and there might just be emptiness. We sit and wait for light to bring us the bigger and bigger and bigger universe beyond. Right? It's like staring through the fog. You've just got to wait. And then we'll look next at how we measure the movement of stars.